Hello bachcho, let's read the question. The question says here, as per chemiosmotic coupling hypothesis in mitochondria, protons accumulate in the. So according to the chemiosmotic coupling hypothesis. So chemiosmotic coupling hypothesis. So this is proposed by Peter Mitchell. This is proposed by Peter Mitchell in 1961 to 1966 in between. So he is a Nobel Prize. He got Nobel Prize in 1971 for this hypothesis, that is the chemiosmotic coupling hypothesis. So this is the widely accepted theory for the oxidative phosphorylation. So this is accepted theory for oxidative phosphorylation. Oxidative phosphorylation. So in this case, reduced NDA. So reduce NAD, nicotinamide. So reduce NAD. That is what is the reduced form of NAD when we added a hydrogen to this compound. So this is the reduced form, that is NADH. So the reduced NAD released from. So this is released from Krebs cycle. Krebs cycle. When enter in the ETC. When we enter to the ETC. So first of all, this is comes from released from this compound NADH. NADH comes from the Krebs cycle and then enter to the ETC, electron transport system, ETC. Then transports of three pair of H plus. So three H plus ions are transported across the inner mitochondrial membrane. So these are transported across the inner mitochondrial membrane. Inner mitochondrial membrane to the intermembrane space, to the intermembrane space. And similarly in the another case, that is NADH. This NADH from the glycolysis, we get this NADH from glycolysis. We get it from the Krebs cycle, and this can be obtained from the glycolysis and from where? Glycolysis and FADH2. So from Krebs cycle also transported three pair of H plus ion, as we discussed it. So this is obtained from glycolysis, and this FADH is also obtained from Krebs cycle as usual. So these two can transport undergo electron transport system and transport three hydrogen ion from across from the inner mitochondrial membrane to the intermitochondrial membrane. So this is an unidirectional flow. Unidirectional flow of proton. These are the proton molecules. Flow of protons resulting in the accumulation of the proton in the intermembrane space. So these are comes from the Krebs cycle and from the glycolysis and comes across the inner mitochondrial membrane and get accumulated in the intermembrane space, in the intermembrane space. So here the question is asking about where the protons are accumulated here. So as per the chemiosmotic coupling hypothesis in mitochondria, protons are accumulated in the last part, that is intermitochondrial space. So the correct answer for this question is option number C, that is intermitochondrial membrane. I hope you understood it well. Best of luck.